Hi guys, I'm Fahad Ra'id and I'm going to explain how compilers work in less than 3 minutes. Some of you asked me to do that and I did my research and I found this subject really intricate and intellectually stimulating, so hope you guys will enjoy it. First, what is a compiler? Compiler is a program that takes human written code in a high-level language and transfer the program that's written in a high-level language into a program that's written into binary. This binary program can be read and executed directly by the computer. So the compiler takes the thing that we understand to make the program understandable by the computer and execute it. Here's a high-level representation of the compilers. We have on the left-hand side language-dependent stages. These are like syntax and stuff like that. And on the right-hand side, we have the machine-dependent stages, such as register allocation, how the memory works, memory layouts, and all of that stuff. In the first stage, we have lexing, where the program in the start of the process, the program is just a combination of strings that the compiler chops down into tokens. These tokens can later be used for reasoning, stuff like knowing the values of the integer 2. So these are not readable by the computer and they get chopped down and get understandable by naming of token. The process called tokenization. Parsing, we get the list of the tokens that we had, and then we use this token to make a syntactical representation. This syntactical representation can teach us about how the program works and make an organization of it. So here, for example, we get two integers, 2 plus 2, and get assigned to this var name. The tokens get turned into this syntactical representation called abstract syntax tree, or AST. For the third level, semantic analysis, we get this. We use this stage in checking and figuring out the variable type or variable declaration. So we have here set of values, 2 and 2 are both integers. We use it to make sure that the set of integers are both consistent throughout the program. So if here 2 plus 2 is an integer, the computer knows that the result will be an integer too. So if we assign this result to the variable, the var name will be an integer. The computer checks that consistently and makes sure that it cannot be added to another var types. For example, an integer cannot be added for a string, and that wouldn't be correct. As for the fourth stage, instruction selection, we get the abstract syntax tree and turn it into an internal representation. This internal representation is a higher level representation that's almost assembly. It's a really complex. We transform this abstract syntax tree into this almost assembly form that we assign a lot of registries near infinity. We don't have infinity, but we get a number of registers that near to infinity, which help us in the logic later on. As for the fifth stage, register reallocation, we pretend that we have infinite number of registers. So all of those are registers for an infinite number. We get this fake registers in a temporary file. We get an infinite number of registers, and then we assign them. We schedule them, those temporary infinite number of registers, into real ones. So we get the infinite number of registers and transform it to the program, which has a finite number of registers, and make it in an assembly code. So this is the real computer half set of registers. So it's like taking the temporaries of those and assigning them, schedule them to real registers. In this stage, we generate the actual assembly using all the process we had later and previously. So here we get the set of codes that are written in assembly and can be transformed and understood by the computer. And for the last stage, we transform our assembly code generated before into an assembler. This assembler takes our variables and functions in assembly and transforms them into the 1 and 0s, or the actual machine code. So it's get them all in the memory and then can understand them. By now, yeah, I explained all of the stages for compiler, and hope you guys enjoyed it.